13
Yeah.
years ago, starting with Clojure, I was actually hiding the fact that I'm using Clojure. All right. Hi, Alan.
Huh. Thanks for having me.
Thanks for coming. Before we will start, would you mind introducing yourself?
Sure. Hi, I'm Allen Rohner. I'm co-founder and CTO of Griffin Bank. And before that, I was co-founder and CTO of Circle CI. And I've been
Great.
using Clojure since before there were official releases. So like pulling off Subversion.
How did you learn about Clojure, that it exists?
Um, so this was 2006, 2007, something like that. I was reading Paul Graham, and he was saying that he was going to release Arc, which is this new Lisp dialect. And he said the problem with Common Lisp was that it didn't have a BDFL like Python. And so he needed, because like Common Lisp, there were like 5 different versions and they were all fragmented. And that they all followed the spec, but then there was like, if you needed the one that was good at networking and threads, you use this distribution. But then if you wanted the one that was good at like building UIs, you use this version. And so he wanted one Lisp that worked well for everyone, and that needed a BDFL. And so then he was going to make a new Lisp, and then he'd been talking about it for like a decade and hadn't released it. So then I said, oh well, I want to build a Lisp, and so I started doing that, and then just following newsletters and Lisp community stuff, and then I saw Rich released Clojure, and that was better than anything I was working on, so I switched.
That's great. So we were extremely early, Clojure.
Yeah.
And was it difficult to convince others that they should give Clojure a try back then?
I wasn't really trying to convince anyone. I was just writing it because I liked it, and I wasn't in charge of anything.
Yeah. Those 13
Yeah.
years ago, starting with Clojure, I was actually hiding the fact that I'm using Clojure. And when I was a freelancer, besides other things, and when I was building systems, I always said, yeah, it's something like Java. You will get the jar file. You can run it in normal container. And anybody can learn the language. And just over time, I started telling, yeah, it's Clojure, it's a functional language, etc. And based on your experience, does Clojure lead to higher quality code? Or is it that it is attracting developers who want to write really, let's say, high-level code and expressive code?
I think it's both. Yes, Clojure attracts good developers, and then Clojure also makes it easier to write better code.
In what scenarios you think, like, what leads other people? You have hired in Griffin for 100 people.
Yeah,
right?
so it's about 40 engineers.
40 engineers. So you have been through hundreds of interviews, I guess.
Yeah.
What attracts people to Clojure when you speak with them?
I'd say one unifying theme is that it's nobody's first language, and that there are a lot of developers out there who learn Java in school and then stick with Java or Python or whatever, and every single person in Clojure learned something else first and didn't like it. They were looking for something better. So in general, these are people who care about their tools and want something better. And then there are a lot of different reasons why, and I've seen people want to move to Clojure. Sometimes it's because it's higher level, sometimes it's the concurrency, sometimes it's the functional nature, sometimes it's the Lisp. Right?
Yes. Which requires special kind of people, because Lisp, it is beautiful, but it's definitely not beautiful for everybody. And I met people who like it a lot, and other people who just expect algo-like syntax, and everything else seems weird for them. And one of the things that Clojure attracts some people because it's a functional language. There is a great speech by Rich Hickey called, I think it's a value of values. And he speaks about splitting code and values, where when you have purely functional or as purely functional functionalities or functions in your app, and then you have values that are immutable, it makes plenty of things much simpler. Where, for example, you can easily serialize data, you can track how the data flow, you can aggregate them, and so on. Is this something that will work in other programming languages as well? Like if you came back to work with C, Python, which you worked with before, would you use those approaches again?
Oh, definitely. And it's easier in some languages than others. So, for example, like it's much easier to be immutable in Rust than C.
Yes.
But yeah, immutability and a clear separation between functions and values, I think, is a pretty good idea in almost every language.
So you have been using Clojure for 17 years now, right?
Yeah.
That time, have you used any other programming language?
Yeah. Some JavaScript. I've played with Rust, played with Idris. Nothing, not much professionally though.
Yeah, many people know what Idris is. So it's Haskell-like language with dependent types. How was your experience with Idris?
I haven't done much more than like Hello World and reading the book, but it is interesting. I know Rich isn't a fan of types, but I still think there's something interesting there. Not in terms of like, is this argument an int or a string, but there are a lot of other interesting properties that I want to prove about my code that need something like dependent types. So things like, is this function pure? Is it cacheable? Is it idempotent? Does it call the database? Does it write to disk? There are a lot of things in that space that I want to prove. This function doesn't talk to the network, for example. And that's really valuable, and it's really hard to get confidence that it doesn't happen in any other way but static analysis.
Yes.
So
yeah.
I find it interesting.
It seems to me that the way how developers, I don't know any Idris developers. I know people who play. I have met a fair amount of Haskell developers, and I suppose they will be similar in their mindset. They like to describe the world in types first, and then they start writing functions. They do really a domain modeling. Clojure developers are not like this. It seems to me that we start with actions. We try to, if we know that we have to move data from A to B, we call a function to read the data from somewhere. We don't care about the shape initially. And then we start the data to be practical for us. And once they, I believe Pedestal framework, and in a way Datomic, they don't care about the data structure. You just in Pedestal, you just send the data. It was a framework. Now in Datomic, you can store any attribute, and it's just edit. So you play with the data. You don't give any shape to data. Would you say that this workflow is common for you? Did you work like this when you were C developer and Python developer before, or did you have to? Do you even work with Clojure this way?
Yeah, I do. I would say I learned how to do the pipelining style of writing code. Of you start with data in the shape, and then you do a thread last and map filter reduce thing. That was a big epiphany for me learning Clojure, and I think that style is useful, and I would going back to your original, I would continue doing that in, C and Rust if I had to.
Yes, yes. When you work with Rust, do you think it's a productive language?
I haven't done much more than, hello world, but yeah, I've seen the complaints that it's hard to build things, but the results do seem to work well.
Yeah, yeah. I have heard the same things actually, that it is difficult to be productive in Rust. And sometimes it might be because you are pushed to do things that are a little bit too low level, but it might be related to the fact that Rust is done by high level developers instead of intended C++ developers switching to more expressive language and safer language. Let's speak about Griffin. So what is Griffin?
So Griffin is a UK bank. We are B2B and API first. So our customers are basically fintechs that want to move money using code. So there's, if they're building a mobile app or a website, and we're in all kinds of verticals.
So
payments, property tech, wealth tech, like everything.
So you let them open accounts, you let them open sub-accounts, I guess, for their customers, right?
Yeah.
And
So
then,
yeah. So there's an API to create a bank account. There's an API to onboard a customer. So the way this typically works is that a fintech would go to a legacy bank, and they say, we want to do, I don't know, rental collection for, 10,000, 50,000 properties. And then the bank would say, cool, here's one bank account. And then you need to go learn the proper way to collect, ID and name, address, date of birth, and all of that. And then you need to figure out all of the checks that you need to do to be compliant with regulation. And it's a big, expensive process. And instead, we have integrated API, one-stop shop. You say, make this API work, fill out these forms, and we can't guarantee you're compliant, but you're much, much, much more likely to be compliant.
And so at this moment, you are providing accounts in British pounds or only, or do you have multiple?
For now, it's GBP only.
Yeah, I know you are a British bank. I guess there is no intention to be a bank in other countries, but
there is, just not this year. It takes a while. Yeah, the long-term vision is we'll have, an EU license, a US license, and have like the same software running everywhere.
Okay.
Or as close as we can everywhere.
Good, actually. I have never heard about that. I thought the intention is to be the UK bank as a service. So this way you will probably end up global bank as a service.
Yep.
Yes. And I know the banks often have hundreds or even thousands of developers, QA engineers, and so on. But initially, when you were building Griffin, the whole engineering team was 5 people, and you have been on this size for a while. How is it? What are all of those things you have to build? How is it possible that you can build a bank where a significant part is built by 5 people only?
I think the last time we were 5 people was 2019, maybe.
Yes.
So the company was we were 8 people when the offices closed for COVID. So that was March or April 2020. And then we were 25 when we had our first get together after COVID. So that was probably August 21. And we're about 100 now. So yeah, we were probably 12 engineers certainly by 2021. and then yeah,
Yeah. So this initial period when you were, let's say, up to 12 people, um, how was it to build a bank? Is it like climbing a Mount Everest where you know there is thousands of features you have to build, or it's not like this?
it was easier than that because we didn't know how much we had to build. um, it was, it's like a sketch. You start with just the very very basic outline, and then you just keep adding detail. So I'd say it was it was easy because we underestimated the size of the problem, but we made it.
Can you say how much, like in multiplies, uh, you misunderstood how much work will be needed?
Yeah. So we're, I don't know, a couple 100,000 lines of Clojure now. And I thought the original, like the seed round deck, I thought we could be feature complete in a year with, 10 engineers or something. I just didn't understand the scope of the problem.
The scale of the problem.
Yeah.
Um, what is a bank? When you speak about like all the systems you have, what are the big of the bank system?
Yeah. So there's the ledger, which is just double entry accounting, lists of credits and debits. But then there's bank accounts, which are the business rules around so a ledger is just a pool of money, and then a business account has rules and logic around who can open an account, when are they allowed to take money out, who is allowed to make instructions on the bank account. Then there's payments, which is the actual messages in and out from other banks to our bank about, Alan gave Jerry 20 pounds, those kind of, and so those, that touches bank accounts. There's onboarding, which is making sure we've collected all of the information that we need to allow somebody to open a bank account. So generally in the UK, that means, if you're an individual, that means you need name, address, date of birth, and photo ID. But then it gets a lot more complicated when you deal with all of the other corporate structures, limited companies and partnerships and trusts and all of those things. Those all have much more complicated rules that build on top of, how do you verify an individual turns into how do you verify a company that is made up of, a board of 5 people
Yes.
and has
Yes.
shareholders and that whole thing.
Oh, I lost you for a second. Yeah.
Let's see, there's transaction monitoring. Then there's all the boring SaaS stuff, user accounts and invites and emails and roles and permissions, and passwords and 2FA keys. That's a whole thing. And then there's another one of internal dashboards. So, we need charts and graphs and reports about Hello?
Okay, I can hear you and I can see you again. Okay, so we have two parts. We have ledger.
Oh yeah. Okay. So
Cards.
yeah, so the ledger is just tracking money movements, but it doesn't have any opinions about where the money can or should go. So then bank accounts is all of the logic and business rules about, is the customer allowed, where's the money allowed to move? Can a customer create an account? Can they, what state is the account in? Is it frozen? Is it closed? Is it those kind of things? who is allowed to make instructions, who is allowed to withdraw money, who's allowed to transfer money, that whole thing. Then there's payments, which is like the messages to and from our bank to other banks about, Alan gave Jerry 20 pounds or whatever.
Yeah.
There's onboarding, which is the rules about who is allowed to create an account. And like, so in the UK, generally you need name, address, date of birth, and photo ID, and then a photo of a selfie. So then you can say, yes, there's an ID, and also you're that person. And onboarding individuals is fairly straightforward, but then there are a lot of corner cases, like what happens if the person can't find their ID, or what happens if they don't have photo ID. And then it gets a lot more complicated when you get into company structures. So like, how do I know that a company is allowed to have a bank account? It's like, well, I have to verify the company, which then means I have to verify the persons of significant control, which are usually board members and major shareholders, but it gets fuzzy. Then there's transaction monitoring, and then there's all the normal SaaS stuff about inviting users over email and password resets and 2FA tokens and roles and permissions and billing and webhooks. And then there's the internal dashboard, which is, like the admin interface for like resetting passwords and dealing with alerts, you have to use a lot of third-party integrations for onboarding and transaction monitoring. So then when those throw warnings, then somebody has to go look, approve or deny, that payment, or approve or deny that onboarding that person. And then, charts and graphs and reports and
Yeah, fraud detection, admin interfaces, API, sandbox, right?
Mm-hmm.
Where people can try to work with Griffin. It will be another part. What else? You said integration with payments. What about cards? Is this difficult to integrate with payments?
We don't do cards yet.
Mm-hmm.
But I shouldn't say it won't be that bad, but it's another payment scheme.
Yes. And I wonder, Clojure is perfect language to build DSLs. Have you built something like a language that describes banking language, and you use it within the code base, or no?
No, we haven't built a DSL, but we do try to be pretty precise with terminology in the source code. So we try to use the same language that the accountants do, talking about with the ledger, like debits and credits, because we have to make sure we understand each other, and we have to produce reports that say, here's all of the ledger entries from yesterday, and so that that turns into a CSV that the accountants can read, and they need to understand it. So using the same words in the domain model helps a lot.
Yeah. Yes. And in general, when you are building, if I looked into your source code, would it look more like a business language describing a bank, or would it look more like a functional programming language where I am composing transformations of maps, lists, and vectors?
Some of both. So we have most of the business logic. One of the things that we did well is that the business logic is it's not 100% pure, but it's as pure as we could make it. And so it's kind of CQRS and kind of message passing style. And the messages are pretty domain level, so you'd see things like, please apply this journal entry, and then it has list of debits and credits. But then when you get into the actually processing the message, those are pretty standard Clojure, map, filter, reduce things.
Yeah, from what I have found in other videos, so you basically have command query segregation where people are saving. Initially, people were saving those commands or queries in FoundationDB. Then it gets to almost purely functional code, and then it was stored in Kafka, and later you moved to FoundationDB, right?
Yeah. So we're 100% Foundation now.
Yeah.
And that's great.
Do you want to speak about the difference and the reason why you moved from Kafka?
I mean, really, we started with Kafka because we didn't know about Foundation. But we were always trying to build a highly scalable, highly resilient system. And one of my original prototypes used Kafka and Postgres. And then I was working a lot with the first engineer hired, and he convinced me that we didn't need Postgres. We could just store everything in Kafka and rocks. And that kind of worked, but it had pretty significant scaling problems, performance problems, I should say, because if you have one Kafka topic with users, and then another, you need a separate Kafka topic for each unique index that you wanted to apply in the system. And that could be hundreds of them because, for example, you want to know that, here are all my unique user IDs and here are all my unique emails. And you want to know that only one user ID has one email. And so checking that required sending a message to another topic, which requires a disk write to do what should be a read. And that has pretty severe performance impact. And then as we got bigger, it became more and more obvious we needed real queries across, multiple topics, indexes, whatever you want to call it. So we switched to Foundation, and so Foundation is great. I have nothing bad to say about it. But it's fast, it's distributed, it has strict serializable transactions, and you can build real database stuff out of it. Oh, and you can build queues in it very efficiently, which is it's great and unusual in that, almost anywhere else, like if you're using Postgres or something, you'd have to also use Kafka. And then you have two places where you have state and they can get out of sync. But in Foundation, you can build an efficient queue and then in a single transaction, take something off a queue and then do database stuff and commit. And that both of them are in the database.
And then you have all the data in Foundation. Initially, I guess the whole database can fit on one server. But then once it becomes too big and you plug in second server and third server, how are the data distributed? So you keep...
so Foundation is a cluster. So Foundation was built to be basically a competitor to DynamoDB, but self-hosted and with strict serializable transactions. So Foundation was a Silicon Valley startup, and then they got acquired by Apple. And then it was closed source for, 5 or 10 years or something, and then it was re-open sourced in 2018, 2019, something like that. But Apple runs Foundation for all of iCloud, and they've benchmarked it at 1 million transactions a second.
Okay.
Okay.
And do you know how Foundation distributes the workload and the data? Like you say, okay, it might be that you say, I have 10 instances, I want the data to be at least on 3 instances, and it does everything.
Yep. There are some great videos on how Foundation works and especially how it's tested. I plugged one of them in my Clojure Corner talk, but I'll do it again here, which is Testing Distributed Systems by Will Wilson. Deterministic Simulation Testing of Distributed Systems by Will Wilson. Excellent, excellent talk.
Great. Yeah, I have to watch it. Okay. And so you said that the Griffin code base is almost purely functional. What are the situations where it can't be purely functional?
So almost all of the business logic is based on these event processor things. We call them procs. And so it's a very, very small protocol of, this is a key value storage, or this is feat storage. And we can talk about feat in a second. But so then a proc gets a message and then a storage protocol, and that's, like get key, set key kind of thing. So that's the one place where it's not purely functional. I'd be interested in getting that to purely functional, but we have to tweak it. But I would say getting it 90% functional has been great, and getting it to the point where procs have no other side effects but what's in that one narrow interface has been great. I highly recommend keep your business logic separate from your from your database implementation, from your queues, from your calling APIs. Like, make it as pure as you can, make the interface as narrow as you can. That's been great.
Okay. Would you mind to say what layers does Griffin have? Like, when you call the API, how many layers it goes through and what these layers are?
Yeah, so the API is a pretty standard ring server, and then it creates one of these event messages, which is just a Clojure map, and that goes onto a queue. And then there's a pub. The log processor stuff is this. It's a pub sub thing, so like I listen for event type foo, and then I emit, foo handled or foo created or whatever. So, some things go through one event handler, some go through 20, it varies, but yeah.
And one event handler is always one database transaction that happens atomically, right?
Mostly, yeah. There are a couple cases where, like, if you really need to call a third-party API, then it would be, event API message in, I'm going to do some processing, and then I'm going to say, okay, it's time to call the third-party API, and that goes onto a separate queue. And then that gets handled somewhere else. So then, in that case, you'd split the transaction. But a lot of it is in a single, it's in a single transaction unless there's a good reason for it not to be that way.
Yeah, it seems pretty straightforward. So when you hire a new person, what steps do you take, and how difficult it is for this new developer to become productive?
Our code base is a little complex. Like like I said, it's a few 100,000 lines now. And the way we do things is slightly, it's a little bespoke. But I would say one thing that continues to surprise me is how deep the domain is. So like banking isn't one thing. Like you can, even for non-engineers, like someone who joins, a legacy bank not as a software engineer, like there's like 5 different career paths there, like that will never interact. You can go into accounting or risk or compliance or operations or financial crime and know nothing, like, and those are all completely separate disciplines, and like you can't hire, you can't hire an operations person as a risk person, because it's like they're completely separate career paths. And so then, inside of engineering, we have to have teams that understand those because you have to, the code has to fit the domain. So it continues to surprise me how deep and complex the domain is because it's not, because it's not one thing. So I'd say onboarding takes a while, partly because of that as well. So, but we try to write a lot of stuff down, and we give new joiners tours through the code base. Here's a tour. Here's generally how things work. You start at the API, and the message goes this way, and then it goes this way, and it goes here, and it can go here, and here's where it comes out.
And is it all Clojure? Clojure on backend, Clojure on frontend, or Clojure script on frontend?
Yeah, pretty much.
Okay.
Yeah, the backend is entirely Clojure. The front end is Clojure script. The public websites are JavaScript, like Node and all that. But yeah.
So when you hire a new person and it's all Clojure script, is it easier to take experienced, let's say Java or C# developer who has been working in banking for a decade to become Clojure and Clojure script developer on Griffin? Or is it easier to take experienced Clojure script developer who was building any web app but nothing related to finance, banking, or fintech?
I'd say it depends on the person. Both could work. And we do have experience. We've seen both cases working.
So how do you evaluate people? Like when somebody new comes, says I want to be a developer at Griffin, how do you evaluate the person will be a good fit and will become productive soon?
It comes out in the interview. So I guess our interview process is a small amount of homework and then, a few engineer interviews. I'd say one of the biggest predictors is like curiosity and like wanting. So curiosity and then like wanting to make things better. Because if someone's just like, you assign tickets and I do tickets, like that's not adding much value. But if someone's like, I want to understand this and like we're doing this and I think it could be better if we did this, like great.
Yeah. From the original team, let's say those initial 8 people, are all of them still with Griffin?
I don't even remember. We've had a surprisingly few number of engineers leave. Yeah, our churn rate is incredibly low.
That's great. That's actually great. I think it must be helping a lot, especially if it's so deep. I was looking at the API, and it seems to me that even when the domain is so big, there is not that much API. There is not that much to implement, so the company can start using Griffin. So what must the company do to get onboarded?
So we haven't been able to automate DC on our direct customers yet. We want to get there, but we're talking about how it's easier to onboard an individual than a company, and companies can vary in complexity because, for example, a simple company might only be owned by individuals, but a thing you frequently see in startups is, they take VC money, and then that means that a company, the VC is itself a company, and they might have, 20 or 30% ownership in this fintech, but then the VC's corporate structure can be incredibly complex, and so onboarding DCs automatically means you have to understand that whole company structure automatically. And that's, it gets even more fun when you have, a British company takes investment from, a Swedish VC, and then, you have to even figure out like what is a Swedish company, and like where do I get the information about it. So that part has to be done manually. But yeah, it's because of the complexity and the size. Becoming a customer for Griffin is closer to an enterprise sales process. But then once you're in, we try to make it as easy as possible to onboard the fintech's customers.
Are you going to support, or let's say, let also companies that treat cryptocurrencies to have an account with you?
Possibly. It's yeah. The tricky part is banks are regulated, and there are rules about what do you have to know your customer, and you have to do transaction monitoring. You can't send money to people on the sanctions list. And crypto, frequently they say, a very common refrain is, oh, I got a very poor customer experience with my bank, so I'm going to use crypto and I'm going to circumvent all of that. And sometimes that's breaking the law. and sometimes it's not breaking the law, but it makes it very difficult to be certain that you're not breaking the law. Patio 11 has a couple of really good articles about that recently. In the US, they were talking about crypto and debanking, and Patio 11 takes a very clinical view of like what's going on and why. And so, yeah, we're not saying no crypto, but like we have to be comfortable that we are satisfying all of our obligations.
Yes. It's a great article, actually. He was speaking about how he was debanked a couple of times, even when he had not crypto. Just you move elsewhere, you change jurisdiction, and suddenly if you are not in the UK, but in Isle of Man or Jersey, even when it is British overseas territory, you might lose your, even when you are still speaking English, pounds, have the same postcode as others in the UK, and still you might lose the account. And in cryptocurrencies, there are more red flags. At the same time, I got to a point where, for example, I was paying a couple of colleagues, or I am paying a couple of colleagues with Bitcoin because, for example, sending money to Peru, for example, can easily be $45 for us to pay, $15 for them to receive. Or you might have banks that take up to 15% to convert to local currency. Argentina, Brazil used to be like this. I think in Argentina this still might be a case. When you use Bitcoin, you bypass all this, and it's still legal. You can receive payment. And illegal on that in Brazil or Argentina. But for those people, if they don't know, they might be spending too much on fees, conversions between currencies, and so on. All right. One of the reasons why you might have been able to implement a bank initially in, let's say, less than 10 people, now in 40 people, is that banks must be backwards compatible, and there is a lot of legal legacy. So the laws might change the ledger. There might be a regulation that will change the shape of ledger. So you need to keep the old shape, you have to keep the new shape of ledger. This makes everything slower, more difficult, changes. If Griffin will be here in 2 decades from now, I hope so. How can you know that Griffin is not going to end up a classic bank with plenty of, let's say, processing being slow, like existing?
I'd point to a couple of things. So I think the number one problem is most banks are not technology companies. but they need to be. They've always been buyers of technology, but you can probably count on one hand the number of banks that built their own core banking stack.
Yes.
And I think that's a huge, huge advantage. I was talking to a Clojurian that you've heard of a couple of years ago. He was working at Capital One, and his boss, his first day, his manager came to him. He's like, "Okay, I've got this project. I want you to dump this data out of mainframe number one, and then put it in mainframe number two. How long do you think that'll take?" And he's like, "I don't know, a day, a week? Let's say a week to be conservative." And 3 months later, the project was canceled. And it's just because it's the old banks tend to accumulate competitor. Like there's a lot of M&A, and then they now have two mainframes that they don't own. Like they own the physical box, but they don't own the software, and they don't have the right to change the software. And even if they have engineers, they don't have the source code. So don't do that. Like build your own core banking system and be a technology company. And by be a technology company, I mean like have a CTO and have them report to the CEO, not to anyone else. So banks should become technology companies. The other big thing is like they don't automate, and maybe that's maybe that's partially a side effect of these old mainframes. But like some of the legacy banks categorize themselves as the largest technology companies in the world because they have like 100,000 people doing Excel. It's like copying Excel sheets from like downloading an Excel from the SharePoint and then doing some transformations and uploading it over here. That's not technology. So like automate all of that as much as possible. Don't go to Excel, and don't have humans running map filter reduce on Excel.
Yes. So this reminds me, I was speaking with one developer. It wasn't a bank, it was a mobile operator. And he told me that a system sends him once per day XML file. And he copies the XML file from his email and pastes it into text area, where he continues the integration and propagation to other systems. And this is one of the reasons why sometimes you make a change and it takes over 24 hours to distribute across the system. Or I have seen, there were times when banks could have turned the system off for weekend, or when transactions were not arriving during weekends because there was a step and somebody had to be in work for things to happen. And it has disappeared more or less. Now transactions seconds, but it has been
Right. We still see it. Like we get emails from other banks that we're having 2 or 3 hours of scheduled downtime, and there'll be no payments in or out during that time.
Okay, so you have to put it to the queue, and it has to wait on your side because no API, right, during that time. Okay, so you need somebody 24/7 to react to those situations, right?
We have engineers on call. Yeah.
When you send money outside of the UK, so does it work through correspondent banks? You have like a limited set of banks you interact with, or the customer can potentially send money to any bank in the world?
It depends. We still have to figure out how we're going to do that. But yeah, at first we'll partner with most likely we'll partner with other banks, and then get our own licenses in a few countries. We'll never have licenses everywhere, and nobody does. But
yes, nobody does. Yeah, I wondered like what would happen if somebody opened a bank account in Isle of Man, Gibraltar, Jersey, Guernsey, and wanted to receive money from British bank. Whether you can communicate directly with banks you have no relationship with, or you always have to go through banks you already know and you have integrated their APIs.
It depends on the payment schemes. So sometimes, so like in the UK, there are three main payment schemes: UK, FPS, BACS, and CHAPS. And so, if you're, it's kind of like the internet, where if you're on the network, you can send money to anybody else on the network.
Yeah.
And then the sizes of those networks vary. So then the EU has its own networks and the US has its own networks. But then if you want to send money across that, you need somebody who can bridge them.
Yes. So which will be a bank that's connected to two networks.
Yep.
Yes. Let's speak about how is it to be a CTO when there are 40 people.
It's nice. I don't know.
How does your day looks like? What do you do most of the time?
So most of the engineers are in the UK and the EU. I lived in London for 4.5 years, and then I moved back to Texas. So my morning is UK afternoon. So in the morning, I get on my computer, and then it's like Slack and email and meetings, solid for 3 hours, and then by my afternoon, most people have gone to sleep, and I mostly write code.
Okay, so you are still coding. That's great. Great. What's your process? What editor do you use, and etc.
Emacs. I've been using Emacs for 20 years. What is my process? I don't know. I just cider and REPL and just
no Copilot.
Sorry, no what?
No Copilot. Do you use any ChatGPT?
No.
No ChatGPT. Interesting. Have you tried to get any code generated?
I haven't tried. I've seen the output of other engineers. I've been pleasantly surprised. I've seen people paste stack traces into Claude and gotten back interesting results.
Yes. At the same time, I must say that the more mainstream the language is, the better all of those pilots, ChatGPT, Claude are. So, for example, when you want it to implement React component or simple API in Python, it works much better. Like ChatGPT, for example, for work with the database, it still loves Psycho PG2, which is a library for Postgres, while there is already version 3. So there are things, but more or less, it proposes libraries that exist, it uses them correctly, the code is good. In Clojure, it constantly hallucinates libraries that don't exist. And it is because there are not enough, let's say, Clojure repositories out there. There are, like for example, now, if you have heard about DeepSeek, it's a software it's open source, MIT licensed model, created by a Chinese lab, actually. So I tried it. It generates better Clojure than GPT, but still it hallucinates. So actually, I wonder what will be the influence of copilots on the success of niche programming languages. But at the same time, what if we will be able to train these tools on our own code basis, so we could teach it? If you have hundreds, thousands of lines of code, this is definitely enough to train some bot or some, let's say, network to write code for you that will be the same quality and it will look like the code you are writing in the company.
Mm. But I would say one of the thing that I spend most of my time on is how do I make the system simpler and more reliable and faster. So like I'm not there to crank out features. I'm there to make the other 40 engineers more efficient. And
Yes.
so like I don't most of Rich's insights were in like how do we think about the problem to make it simpler and easier for humans to reason about. I think a bot is going to have a hard time saying like, oh, you should just avoid mutable state because humans aren't good at that. It's like that's not the kind of insight I expect an LLM to have.
It's one of those insights. It might be one of those insights, but yeah, there were many. In all talk, find multiple insights. One of the things I noticed is you are using property-based testing, which helps to test the system in many different scenarios. But at the same time, how long does it take to run the whole tests for the whole Griffin code base?
It's not easy to answer that anymore. So we use Bazel, Google's build tool, and Bazel has both test caching and remote execution. So you run a CI job. So Bazel behaves kind of like make in that, if the source file hasn't changed, then it won't run the build step again. But it can also do that for tests. So it says this test depends on these files, and if none of those files have changed, I don't have to run the test again. So that's test caching. And then remote execution, you can give it a cluster of machines or GCP or serverless or any of those things and say, here are the tests that need to be run, go distribute that across 100 boxes. So our test suite now, a full build, like if you made the entire thing dirty, it would take 45 minutes on 100 machines.
100 machines.
But if you don't touch anything, it's 3 minutes.
Mm-hmm.
So I'm not sure what the total test execution time would be on a single machine now, but certainly many hours.
Yes. And in property-based testing, so you generate a list of cases, and then you run all of them, and then when some tests don't pass, is the next step that you try to find a minimal case that leads to the test not passing, or?
Mm-hmm. Yeah, usually it spits out a seed, which is the random number generator seed that produced those inputs, and then you just run that manually, and then you're at normal debugging.
How many cases are in the seed for one test on average?
Depends on the size of the test, but so like if you have very small pure functional code, it could be thousands of tests. But if you have like a bigger kind of integration test kind of thing, it might be 10.
Yeah, I get it. Okay. Do you find a lot of bugs, or
Yeah,
is more?
it's really helpful. And even more than finding bugs, the maintaining the test suite gets a lot easier because you say, if you say my function takes an A and produces a B, and then you change the function to say, well, actually it accepts A or C and produces B, then your choice is either copy and paste your example tests or you change the generator on your property test to say now it can produce an A or a C. And we frequently find bugs where the generator was either too broad or too narrow, and so tweaking those is pretty easy too.
Yeah. Also, I believe it must be helpful when you have new people joining, and if there is a lot of depth in it, if this depth is projected into the test, into test, it will be easier to find all problems that
Yeah.
newcomers introduce.
Yeah, and it helps you with design too, because your examples can quickly become combinatorial in complexity, because I have this message that has these 10 fields, and then this field can be an A or a B, and this field can be a C or a D, and this field can be a D or an E. It's like, well, did you really test all of the cases? Like, you probably didn't. Like, as a human, you're just like, oh yeah, I'll just do one example with everything from the left column and one example with everything from the right, and then you forget about, oh, what happens if this is an A and this is over here is an E? And you actually find out, like, sometimes, like, maybe we shouldn't even allow that case, like, as an input.
Okay.
So yeah, it's been nice.
When this happens, you really go and generate seeds to all potential combinations, unless you decide that this combination should not be allowed.
Yeah, it helps expose that thinking.
How long have you been using property-based testing?
Certainly since before Griffin.
Okay.
I don't remember when test.check. Maybe a year or two after test.check came out. Yeah.
Okay. Great. So now, is there anything how people can support you in what you are doing in Clojure? For example, does Griffin have any open source people can contribute to?
Yeah, we have one right now, which is Rules Clojure, which is the Bazel plugin for compiling Clojure. There's more stuff that we should open source, but just haven't found the time yet. And also I have to fix like Bazel stuff to make it easier to consume. So like right now we have support for Maven targets, but we don't support the git SHA thing in depcdn yet. So I need to do that to make it easier to use our own code.
Yeah. Yes. By the way, to work with Foundation, is there a Java library or Clojure library? Did you make a library yourselves?
Yes. So they're Java bindings. So Foundation by itself is just a key value store with transactions, but it's built to be able to build other layers on top of it, which is why it's called Foundation. So like they used to have a SQL layer. Before they got bought by Apple, there was a SQL database on top of Foundation, and then that disappeared when they got acquired, and then hasn't been re-open sourced yet. But there are a bunch of other layers. So like there's an official one called the record layer, and then we built a Datomica-like thing based on DataScript on top of Foundation.
Was it difficult to build such a thing?
No.
No? No. What do you use it for, if I can ask?
What do you mean, who's it for? Like, that's what the Griffin developers use.
On top of Foundation. So you use it as a generic, let's say, Datamake is often used either as a graph database or document database. So is that your use case?
Yeah, it's the database.
Yeah. Okay. Thank you very much. It was great.
Thank you.
Let's speak again in the future.
Yeah. Thanks for taking the time.